This episode of the Electric Samba project, we're going to talk about the whole charger saga. All the troubles that we've gotten along the way just to charge our batteries. So welcome to another episode of our project. There's a lot of stuff that has happened, and it's always happening on the Samba. We keep working on it all the time, and we don't always record video of all the stuff. But one of the things that's happening that we can't really talk about is the battery. We've recently have replaced the battery with this new battery technology. I think it's going to be very exciting, but we can't talk about it just about yet. And so that's going to be for a future episode where we're going to really be able to talk about it and run into a lot of the tests that we're doing and stuff. It's going to be really exciting. One of the things that we struggled with on this last episode was on our trip to Solving, our charger gave out. And this is not the first time that our charger has given out, because since the very beginning, we've been struggling with it. And just to catch you guys up on what their story has been, let's go through it. I started working on this car, and I decided that I didn't want to buy a store-bought charger or something that was available at that time. And the reason was because they're usually too expensive, they were big, and they weren't very programmable. So basically there was a lot of struggle. Like this guy, for example, like you can't change your batteries, you have to send the unit back and have it fixed, or you have to figure a bunch of stuff out. So it wasn't very easy. And I knew that I was gonna be messing around with different battery setups and different battery technologies and stuff. So it didn't really fit my needs. If I wanted to get one that was programmable, it was really, really expensive. We're talking about $3,000, $4,000, $5,000 for a charger that, you know, was decent enough to charge batteries. One of the sore points in the electric vehicle up to this point is still the long times that it takes to charge the batteries. So there's always a race to try to shorten that time by getting a big charger and stuff. So I decided to go with an open source charger that Electric Motor Works makes. And that was a 10 kilowatt charger, and it's this guy right here. This big square box that you see here. When I bought it, I bought one that was a kit. And basically you buy all the stuff, and it's all like in parts and stuff, and you put it together and you follow the instructions and stuff. And then you have your charger. I have very limited experience with electronics. I've done several other kits, and I kind of understand the basics of electronics and stuff. So I thought, oh, piece of cake. I can buy this thing, put it together, run it through tests and stuff, and then get a charger that will work. As it turns out, I couldn't really do it. I struggled for, a couple of months trying to put this thing together. And, a lot of it was my own ignorance on how this thing works. But a lot of it was also that the kit was not really well put together. You get a bunch of parts that are unmarked. So then you spend all this time trying to figure out, what is this thing? Is this a resistor? Is this the diode? What is this? There's just no markings on them. You have to do a bunch of research. The documentation, it was very lacking. There are components that look exactly the same, and there's nothing that tells you how to tell them apart. There wasn't even warnings that say, make sure you get the right one because these two parts look exactly the same, but they're completely different. So we struggle a lot with that, and I wasn't able to put it together. I'd say it was 50-50, that I didn't have what it took to put this kit together. And 50% it was just bad documentation. And I understand, Electric Motor Works is a small company and stuff, and they're doing these kits almost for no money. They could cater to that market where, people don't want to spend a lot of money and they want to get their hands dirty and stuff. What I ended up doing was I sent it back to Valerie, from Electric Motor Works. At that point, FCON was coming around, so I needed a charger. I needed to have something that worked. And so what I did, I just bought one that was already put together and was working. And that was great. It was a nice little unit that had water cooling on it. And it was an older unit, but it didn't matter. It worked just fine and stuff. And I used it for a good 4 or 5 months until one day I was really trying to push it through its limits. and I was using a 50 amp Anderson connector and trying to push 70 amps through it. So essentially what happened was like the connector got so hot that it started melting and then it shorted out. I just sent it back to Valerie. So Valerie at this point would have 2 of my chargers, and he's gonna fix them. He's gonna evaluate them and look at them, troubleshoot them, and then he's gonna tell me, if it's worth it to fix them or, whatever. The problem was that he's very slow, and I think he's run around with too many tasks. 6 months went by and he didn't get me a charger, and I don't have a charger. Michael Breen from EV West was very nice enough to lend me a charger, and I used it for 6 months, and it was a great charger. It was a Manzanita Micro, a PFC 40, which it's cool because you can adjust it, how much you want to charge it and stuff with the simple dial. You can adjust the voltage and stuff. The problem is that it wasn't very fast. It puts like 40 amps into the battery pack, so I think that's like 5 kilowatts, 4.5, 5 kilowatts or something like that. So it wasn't very fast, and it's kind of expensive. I thought about just kind of giving up on these open source chargers and stuff, but it's still like $2,600 for that charger, so it's still kind of up there, So I decided not to give up on this chargers, the open source one. I started kind of bugging Valerie on the forum and stuff, and I called him up a few times and said, hey, it's been 6 months since it took 2 of my chargers and there's just no follow-up. So what's going on? Can we work on something? Eventually he did. He drove all the way down to our office here and he delivered a brand new unit. He didn't bring either ones of my chargers that I had sent him, but he just gave me a brand new one, which, I didn't complain. I needed a working charger. He brought me a working charger. Fine, So I installed it in my eSamba, and this is the first charger that I actually installed permanently. All the other ones were kind of floating around, and it was fine. It was working fine. I was noticing that the air cooling thing wasn't working. It works great here on this table when you put it out here, but as soon as you throw it in the car and it's cramped and there's not a lot of good airflow in there, then it was running kind of hot. And I was meaning to design, maybe take it out of this air-cool heatsink and then put it in a water-cool or liquid-cool version. But, I was going to eventually get to that, And so when the opportunity came, a few weeks ago to do this long trip and now to test out our new batteries, we decided to take off and see if we can make the 300-plus mile trip and just see what the adventure would be to just travel long distance and trying to find chargers and stuff and a place to charge and just make it. So that's when we run into the problem that this charger just kind of gave out. It was charging fine, I stopped charging, and then the next time I pulled up into the next place to charge, it stopped. It just, and there was no warning, there was no nothing, it just stopped. At this point, I got to figure out what I'm gonna do, and I don't feel that I'm capable of diagnosing what's wrong with it. And the only thing that I could do would start changing parts. If the IGBTs were the ones that broke or died or burned or whatever, I can buy those, and I know where to buy those, and I can change that. If that wasn't it, maybe if the IGBT driver gave out, I can buy and order those and change. I can pretty much start changing all the components until I get a working charger again, But because my time lately is so limited, I'm back here at Jack 35 running this place, and my day consists of, packaging, going picking up parts from the anodizer, drop off parts at the post office, and all this other stuff. I decided that I wasn't gonna work on this charger, and I just was gonna start from scratch. It was gonna be quicker because I don't have to troubleshoot any of it. All brand new parts and install them, run through the little instructions. At this point, this is like version 14 of this charger. The instructions have gotten a lot better. They have pictures and all this stuff. So I think I can attack this and I have a better rate of success, I think. So that's what I decided to do. Since I decided to start working on my own version of a liquid cooled charger, I also decided that I can't have the eSamba part. It's like I worked so hard to get it to where it's at now that I can't just park it and not drive it. In fact, I was 2 weeks that I didn't have a charger. Every free minute that I had, I was kind of working on this thing to try to get it working as fast as I could. I was finding that I was kind of feeling depressed because I couldn't drive my eSamba. You know, it's getting to that point where it's so much fun to drive it, and you know, it's such a big part of my life now that I decided I can't wait for me to get this done. You know, this is gonna take a little while, you know, maybe a month or two or whatever to get this one done. So I just had to go and buy one of the most affordable chargers there are. This is this Elcon or TCCP or something like that. These chargers are great because they're kind of affordable. It's about 1,500 bucks. It's about 5 kilowatts, but if you see the difference here, it's about twice the size, twice the weight, and about half the power than this one that I'm working on here. This one's going to be currently about 15 pounds, and it's going to be able to output about 10 to 12 kilowatts depending on your battery voltage or whatever. So the attraction to this open source charger is it's a lot because you don't have to put hundreds of pounds and you don't have to spend thousands of dollars to be able to have a high output charger. And to give you an example, this charger here with the 45 kilowatt hour pack that I have on my eSamba, this is a 10-hour charge at full power. So it's quite a bit of long time, you know. With this open source, once I get it working with the liquid cooling and stuff, I can get it outputting 10 kilowatts. Then you're talking about 4.5 hours. For the same size and weight, I can have 2 of these units, which I can then be doing 20 kilowatts, which is now we're getting really fast. You know, I mean, we can charge our batteries for under 2 hours and have 150 plus miles of range of that. So I think that's the holy grail right there of electric vehicles. Tesla's doing great with their supercharge stations. We are kind of lagging on the DIY world and stuff, and I think this is the key here. We need a charger, a supercharger for our DIY builds, and I think this is it. It's right here. It's kind of buggy, you know. It's like you got to figure it out. You got to build a couple of them and blow a couple of them before you can figure it out. But I think that's the aim here, you know, and that's the target, you know, to be able to build and get to know this charger so well that we can put it together in our sleep and then still be able to build a couple system where you put a couple of them together and then have super fast charging. So that, you know, people that say, yeah, I would love to have an electric car, except, you know, it's like, it's not quite there now. You can't charge fast enough. It's like, yeah, now you can. It's like 2 hours. You can have 150 miles of range in your drive. So that's the project here, and this is what we're gonna do it. Let's take a look at exactly what this piece looks like now. So let's discuss a little bit about the design here of this charger. It's a pretty simple charger. It's a switching power supply basically. And the cool thing about this, it's fully programmable. You're able to do AC anywhere from 80 volts all the way to like 500 volts, and you can do like 3-phase. You can use this anywhere in the world and almost any power. And not only can you do AC power in, you could also do DC power in. So you could take a battery pack, maybe if you have like a solar system and it charges a battery pack, well, you can connect this directly into your battery pack, and then you can do some crazy charging speeds. I mean, this thing could output like 50 kilowatts, you know, when it's doing it that way. It's a pretty versatile piece of gear. It's all being controlled by an Arduino Pro Mini. It's got a couple of big semiconductors or IGBTs, which are just basically big transistors. It's just basically a bunch of caps here to regulate, to kind of stabilize the output power, and then an input inductor, and then the output inductor. And the input inductor is a PFC, power factor correction. And this is basically to clean up the input so that you can really take the spikes off of the draw, off of the wall, so that it won't trip the breaker before you hit what the breaker is rated at. So if you connect it to a 20 amp circuit, you can get really close to that 20 amps without tripping the breaker. So it's a very nice unit. It's kind of simple, but it's pretty powerful. And like I say, the main problem is keeping everything cool so that it doesn't burn the IGBTs, the big transistors, they will fail if you run them hot. The power inductors here also get very, very hot, so you need to cool them down. And even on the water cool version or the liquid cool versions that Electric Motor Works has done in the past, the inductors are really not cooled via water or by the liquid cool. They're still required to run a couple of fans just to cool down the inductors. So what I'm doing here is having a plate that I'm gonna screw on top of this plate. This is a plate that is designed for the Curtis controller, and it's being offered by EV West. I was gonna make my own plate, but I thought, well, it's roughly the right size for it. And EV West is already making it, so it's kind of cheap. I think it's like, you go to their website, it's like under $200 for this little plate. And it's very well made, it's well machined and stuff. And so what I'm gonna do is put this plate where I'm gonna mount all the components of the chargers right on top of that. And it's got an inlet and an outlet, and so that's gonna just cool this entire plate. And that's gonna cool all the power electronics, the two IGBTs and the main rectifying diode board here. To cool the inductors, what I'm gonna do is I'm gonna make some aluminum pieces that go on top here, and then I'm gonna use thermal epoxy to encase these two inductors in there. And basically they're gonna be glued, they won't be able to move, but they're gonna be encased in thermally conductive epoxy, and hopefully that's gonna keep it cool. This version of the charger, Valerie did a thing where you can put two different thermistors, which is these little devices that allow you to keep track of the temperature. And so one is going to be over here to kind of keeping an eye on the semiconductors temperature, and then as the secondary one is going to be over here close to the inductors, so that you can see both of the temperatures. And so that's the plan. Here's how they look in our CAD program that we're designing. You can see that on top of that just single plate, this is a nice casing that I'm going to design, and I can make it look as fancy as I want, or as simple as I want. But it's going to be pretty small, and we're going to be able to put a couple of them in the space that what Valerie sells off of this website. And so that's the plan. In the next few weeks, I think we're going to be able to complete putting this one together, and then run through its test and see if I got everything correctly. And if not, then we're going to go back and see how we're going to troubleshoot this and stuff. But so that's the aim here. All right, so that's the plan with these chargers. I think, like I said, it's pretty exciting times. We're trying to get these superchargers, to compete with Tesla and stuff. And I think in the next couple of weeks, we're going to be able to make strides in this project and be able to have something we can show you and stuff. Especially now that we're getting the Samba with 100 plus miles now on it worth of battery, which is a huge battery. 100, it's like a 45 kilowatt hour pack. And I'm thinking at this point I'm going crazy, and I would expect to maybe go as big as 50 or 60 kilowatt hours in the Samba, because these new batteries are very exciting. They're very small, they're very light, and they fit in other places where the other ones didn't fit. So we definitely have a need for this fast chargers and stuff. So stay tuned for the next few episodes coming up in the near future, where we're going to be testing these guys, and we're going to be taking more road trips and see if we can do the whole experience of long range traveling on an electric vehicle. All right, guys, so this is this episode of the Electric Samba project. If you notice that I'm not able to kind of keep doing at the same rate as I was doing before, in a weekly basis, but we're still working on the Samba. We'll do it as often as we can. And so check out Win Stacy Game. She also did an episode on this trip, and her angle on that, she was a passenger on the Egg Bus, which also has its own series of adventures. We're always working on that car also, so check those other channels. So stay tuned for the next episode, whenever that is.